Okay, in all of these questions, we're dealing with conditional probability, meaning that it's just like a normal probability, except we have a little bit of extra information that adjusts our prediction of a probability. So this first one, number 5, for example, we're looking at getting a total of 7. So a total of 7 on 2 dice. You can look on a dice map and there's 6 ways to get a 7. The 6-1, 5-2, 4-3, 3-4, 2-5, and 1-6. And just a reminder, the reason that we do count, say, both a 1-6 and a 6-1 is because we have 36 equally likely outcomes. That equally likely part is important. Okay, but it turns out that if we already know that the total is odd, our chances are a little bit different because it factors out all of the possible evens. So using this formula for conditional probability, we have the probability of having both events, E and F, in other words, both an odd and a total of 7. Well, that's just 1/6 because we still have 6 out of the 36 are both odd and they're 7. So that part doesn't change. The part that does change here is this new information, the probability of being an odd total on the dice. And you can look on the dice, half of them are odd, half of them are even. And so when we take 1/6 divided by 1/2, if you need to go through the dividing by fractions, remember dividing by a fraction you would multiply by the reciprocal. So we'd take the 1/6 times 2 over 1. The 2 and 6 would cancel down to 1/3. So now it's even more likely if we know it's odd. The second one, so we have a probability of getting a 4, which would either be a 1-3, a 2-2, or a 3-1. So there's 3 out of those 36 that would give us a 4. Reduce that to 1/12. But and here again on top, the chance of having an even total or having a total of 4, that's still 3 possibilities because 1-3, 2-2, and 3-1 are already even anyway. So we still get all 3 of the same possibilities we had in the first part for the top here. This number will not always be the same, and we'll see soon some examples where they're not. Here the probability of getting an even is also 1/2, just like it's 1/2 of getting an odd. We work this out to be 1/6. Again, you can take the 1/2, make it 2 over 1. So you have 1/12 times 2 over 1, which would be 2/12 reduced to 1/6. Okay, this next one here, total is less than 5. So I've listed them out here. There's 6 different dice combos that would give you less than 5. Out of the 36, that reduces to 1/6. Here's a case where these two numbers aren't the same. So let's take a look at what's happening there. A 3 on at least one of the dice, and the total is less than 5. So we need both of these things to be true. Well, here we have all the possibilities that are less than 5. So we can just specifically zone in on the ones that have at least one 3. And you see one of them's right here, one of them's right here. So in other words, we only have two outcomes here that are less than 5 and have at least one 3. So that's why we have a 2 out of the 36 up here. On the bottom, we need the probability that a 3 shows on at least one of the dice. And you can get this 11 a few different ways. You can look at the map of the 36 dice rolls and get that 11. You could use a formula before. We've calculated this in class. What's the chance of getting a 3? You could look at the chance of not getting a 3 on each one, and that would be 25/36 that you would then subtract from 1. You could list them out, and the main thing you want to make sure there is you don't double count the 3/3. Any way you want to, you can get this 11/36. When we reduce it, the 36 are going to cancel out once we change this into the reciprocal here, and we get 2 11s. Next question. So we want total greater than 5. Um, Notice it's not quite just the opposite of what we had done in the previous one, because we didn't allow the possibility of actually getting a 5. We want the total greater than 5. So you can take 1 minus the total 5 or less. So it's basically the ones we had in the previous question plus all the ones that total 5, and there's 4 of those. 1, 4, 2, 3, 3, 2, and 4, 1. So 10 total ways to get 5 or less. We want all the other ones, in other words, the ones that are higher than 5. So we subtract this number from 1 to get 26/36, reduce it down to 13/18. Here we need the total greater than 5, and we need a 2 on at least one of the dice. So I've listed out the 6 different ways that you can meet both of those criteria at the same time. And then on the bottom, we just need a 2 showing on at least one of the dice. That's really the same question that we ask here to get that 11/26. So we have 6 11s total. 9, you can think of this in terms of the formula, or you can think of this directly. Let's do the formula first. So the probability of drawing a heart if you get a red card. So you know that you didn't get a black card. You know that you've gotten a red card. So what's the probability of getting a red and getting a heart? Well, all the hearts are red anyway, so this is really just the probability of getting a heart, which is 1/4. On the bottom, probability of getting a red, half the cards are red, half are black, so that would be 1/2. Reduce this to 1/2. Or you can think about it, if you've already drawn a card out of the deck and you know it's red, that's the only information you know it's red, it's either a heart or it's a diamond. So you really have a 50-50 chance, a 1/2 chance there of being a heart if you already know that it's red. Here, probability of king if it's a face card. Well, if it's a face card, it's either going to be a jack, a queen, or a king. There's equal numbers of them, so you really have a 1/3 chance. You can also go through the formula here. That should also give you 1/3. What's the chance of getting a 7 if you get a non-face? You could think about this directly, as I suggested for the first 2 of these card questions. Let's go through, it's a little harder with this one to think about it directly. Let's go through the formula. So here we need the probability of both of these things happening, a 7 and a non-face. Well, a 7's already a non-face, so if you get a 7, you'll definitely have a non-face. So this is the harder criteria to meet. So let's just think, what's the probability of getting a 7? And that would be 4 out of the 52 cards are 7s. Then what's the probability of getting a non-face? Well, that's the cards ace through 10, so there's 10 of them in each of the 4 suits. In other words, 40 total. Reduce that to get 1/10. And you could, by the way, think about if you get a non-face card, there's 10 different types of non-face cards, ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. So once you know it's a non-face, the chance that it would be a 7 would be 1 out of those 10 options. Probability of getting even, given that it's a non-face card. So here we need even and non-face. So these are the 2s, 4s, 6, 8, 10 in each of the 4 suits, which is 20. And probability of getting a non-face we've already looked at right up there. Reduce those to 1/2, which makes sense because half of those numbered cards are even, assuming that ace is a 1. 13 through 18, I think it's actually easiest. You can go through the formula and that would be fine. But I think it's easiest to just look at the pictures. So given that it's a yellow, which means you're going to screen out all the pinks and blue. You're going to focus in on those 4 yellows that you see in the pictures. And you want to see how many of those are hearts. Well, there's 2 out of those 4. So given that it's a yellow, how many of them are hearts? 2 out of the 4 are hearts, and so we reduce that to 1/2. Here, pink given a smiley, so you only look at the smileys. Just ignore all the rest. You already have this extra information that you're dealing with a smiley, so focus in on the 4 smileys, and 2 out of those 4 are pink. Number 15, So we're looking only at the hearts, screen out the other ones. There's 3 that are hearts. 2 of those 3 are yellow. So if we know that it's a heart, we have a 2/3 chance of it being yellow. And the comment here I made is when you're doing conditional probability, it does matter what order the 2 come in. So probability of heart given that it's yellow is not necessarily the same as probability that it's yellow given that it's a heart. So the information that you have does change things. Okay, probability of heart given it's blue. So there's three circles there that are blue. Only one of those 3 is a heart. With pink, 3 are pink. None of those 3 are a heart. So as soon as we know it's pink, we know there's 0 chance of getting a heart. And blue, we have 3 blues. One of them is a smiley. Moving on to the tables. The tables are kind of nice because you're really just trying to identify which sector in the table has the information you need. And let's see what I mean by that. So the first one says, the student has mono given that the test is positive. So if you look at that chart, there were 72 positives that have mono, 4 that don't, but the total column there really tells you the total that have that were positive. There were 76 students who came back positive for mono, but we want to know what's the chance that they actually have mono. If they're one of those 76, what's the chance they actually got mono? Well, 72 out of those 76 actually had mono, so we can put that as our probability. Next one, what's the chance that the student does not have mono given the test is positive? So we're still looking at those 76 students whose test results came back positive, but now we're focusing in on the 4 who actually didn't have mono. So 4 out of 76. And here what we see is these 5%, it's important to note what's going on here. These students had a positive test result even though they didn't have mono. So think about this in terms of your life or your loved ones. When you get medical tests and the results come back positive for something, which is a bad thing in medical terms, it means you have the disease or the condition. That doesn't necessarily mean you have it. It's very possible to get a false positive. Here we saw a 5.3% chance, but in many cases it's much higher than this. The point being, keep in mind that these medical tests do have some room for error. Next question, test is positive given that the student has mono. So we're only focusing in on the students with mono. There's 80 of them. 80 of these students have mono. What's the chance they don't have? What's the chance that the test is positive? Well, 72 of them got a positive test, which gives us 0.9. Last one, given the student doesn't have mono, there's 60 students like this. 56 of those 60 had a negative test result. So the probability that we would draw 2 jacks, we're going to break this apart, one without replacement, one with replacement. If we don't replace it, there's a 4 in 52 chance that we draw a jack on the first one, but now we only have 51 cards left to draw from and only 3 possible jacks to get because one of them was taken out. So this gives us 1/221. On the other hand, if we do replace, we still have a 4 out of 52 chance of getting a jack on our first one, but then when we put that jack back, we still have 52 cards to choose from, and we could potentially get that same jack, so there's still 4 possible jacks in the deck. So a little better chance of getting 2 jacks there. Second one is similar, looking for 2 hearts. So 13 out of 52 are a heart, but if we don't replace, then there's only 12 hearts left and 51 of them, 51 cards to choose from, giving us 1/17. If we do replace, the chance the second time is exactly the same as the first. And in general, this will be the case if we replace. And finally, 12 out of 52 are face cards. Now we want a non-face cards, 51 cards to choose from, 40 are face, or not face.